Hello to everybody. I'm really happy to greet all the participants of the International Conference on Science Technology Research. My name is Lyudmila GryzunL. The topic of my presentation, modeling university courses using Petri nets. I'm really happy to represent here the Simon Kuznets National University of Economics, Kharkiv, Ukraine. I work as a full professor of computer science department, where we train pre-service IT specialists for various branches of national economy. I have a PhD and second doctoral degree, and the focus of my scientific interests are among these areas, but my focus is curriculum design and creating of coordinated curriculum design in university education based on knowledge penetration. So the topic of my presentation is tightly connected with the focus of my research activity. Today, I'm going to touch the problems of university courses synchronization and which difficulties arise usually there. Then I'd like to cover the author's approach to the curriculum modeling using Petri nets facilities and the share of discussions of the benefits of the offered approach. Talking about the problems of university courses synchronization in general, it's necessary to say that they are caused by the number of factors which demand the search of new approaches to curriculum building nowadays. Among these factors are the following: quick changes and renewing of technologies, social life situation in employment market, and in general, really a volatile situation, unstable situation in all spheres of our life. Then it's definitely trends of international students and employees mobility, which course international context of higher education in general. Also, the growth of information amount, knowledge expansion, renewing of knowledge, losing their urgency. And definitely the trends of contemporary scientific branches as for the synthesis of knowledge, mutual enrichment, interdisciplinary context of research with interpretation and interpenetration of knowledge and cognitive methods, tools, and so on. So all of these tendencies must be reflected in the content of training of university students today, because the global science and deployment market demands specialists who are ready to solve integral problems, not specific ones, not isolated ones, but integral problems, to have flexible system of knowledge, which are able to use it in related branches and ready to be adapted quickly to changes, to retraining, to reorienting their qualification, and so on. And in this context, it is really important to understand the role of curriculum discipline, of curriculum course for pre-service specialist training today. Because on the one hand, a curriculum discipline is implementation of certain educational content, and relevant modular structure of a course can facilitate the process of formation of holistic and flexible system of students' knowledge and skills, or just opposite, it can damage, ruin this united and whole understanding of the world, the picture, and the system of knowledge. And on the other hand, the curriculum discipline is embodiment of some scientific branch adapted to teaching and learning. So it must reflect correctly the branch structure, at the same time preserving main links between notions, concepts, facts, and theories that really exist both inside the scientific branch and between branches of sciences in the whole. So the main problems which to be solved in the process of content building and curriculum building, how to form integrative content of learning, how to provide modular structuring of curriculum disciplines with preserving links between knowledge, and how to provide their synchronized learning throughout the modules of different curriculum disciplines for pre-service specialist training. All of these problems are not trivial, and they might be solved, and they're really urgent today. The need of alternative approach actually has been explained. It's necessary to develop alternative approaches to the curriculum design based on mathematical and digital tools, which are able to overcome the exposed problems and to cultivate cross-disciplinary strategies of teaching and learning. And finally, to form students' holistic, coherent, and flexible system of knowledge. Key characteristics of our integrative approach to curriculum design are covered here. First of all, it is based on the relevant mechanisms of knowledge integration in scientific branches and in curriculum courses. It provides special technique of discipline structuring, which triggers the integration mechanisms realization, and it results in the coordinated system of curriculum disciplines. The technique of curriculum discipline structure, which was elaborated by us, it is rested on three main ideas of multi-level construction of the content of learning, multi-level knowledge generalization, and we applied models of knowledge representation of artificial intelligence theory. In particular, we used semantic networks and frame-based systems using the facilities of hierarchy and inheritance properties. The technique of structuring can be covered by four main stages. It's so-called super discipline level, the level of curriculum discipline, and the level of learning material of curriculum discipline. Covering the procedures of all of these levels, I'd like to emphasize the following. At the super discipline level, the learning content is concentrated as a network of so-called key points, which are defined based on the analysis of the system of professional functions of pursuing specialists, based on the structure of their activity, the essence of their typical professional tasks, and so on. So they include real, true objects, processes, phenomena, which are to be mastered by pursuing specialists in their university education. On the next stage, which is so-called structure level of knowledge generalization, it is provided the general structure of the subject area and the rules of knowledge manipulation. In order to realize them, we elaborated special technique of preliminary analysis of the subject area and revealed so-called didactic characteristics of academic disciplines. After such an analysis, we could select node learning elements of the subject, and we grouped them around the key points of super discipline level. So formally it is done in such a way, and these selected learning elements, which are grouped among proper key points of the first level of knowledge generalization, all of these learning elements, they in fact make modules and in fact make so-called frames in the terminology of artificial intelligence theory. On the second stage, the hierarchy structure with the frames in its nodes is built, and each frame, which in fact is a table of special structure, each frame corresponds to cycles of training, to curriculum subjects or courses, to the modules with learning elements inside of them. On the third level, the third stage of the discipline structuring, so-called level of learning material, this level will fill in all the frames prototypes of general structure and their slots with exact data, exact values of learning elements, exact inheritance pointers of each slot to provide proper links. After all of these procedures, we obtain a coordinated and coherent system of curriculum subjects, which look like this one. Here you can see the semantic network of superdiscipline level and modules with frames grouped among the proper key points of super level of educational content. So you can see that each course can be represented as a nested system of frames, and each frame consists or covers the system of learning elements with links which are spread and penetrated via the modules. And in fact, we obtain the really sensitive and coordinated system of learning elements, which are sensitive to the changes which usually happens on the super level discipline, super discipline level of education content formation. So the technology to the discipline structuring and coherent curriculum shaping was implemented and verified. However, in the process of real curriculum building, it became clear that it's necessary to elaborate the issue of the grouping learning elements into the frames, which in fact are modules, because it's essential to group them, making into account all the sequences and precedence of their learning within the modules and disciplines in real educational practice. It will make their mastering not only holistic, but also synchronized. In this context, it is relevant to use the simulation advantages of Petri nets apparatus as for their process synchronization. So in brief, to cover the theory of Petri nets and their properties, I'd like to say the following, that Petri net can be defined as a two-part type-oriented graph, which includes non-empty sets of vertices, and among vertices there are two types of them. There are places, which are circles, yeah, and transitions. Places usually represent states and conditions, and transitions usually represent events. Also, there are some tokens moving around the places. Places can accommodate tokens, and moving the tokens around the net can simulate the process in progress. Our component determines a relationship between the vertices corresponding to the arcs. As I said above, in our approach, the disciplines are composed by the frames uniting the learning elements. Any frame has inputs and outputs. Inputs are the learning elements necessary for the student to master in order to be able to learn the learning elements of the frame. And in similar way, the outputs can be represented regarding the other frames. It can be distinguished through different types of the precedence relations between inputs and outputs, between the proper learning elements. And here you can see them. There are three types of precedence relations for inputs: one-to-one learning element, one of K with all precedence relations, and the whole set of K learning elements to one, so-called AND precedence relations. And similar things can be made for the outputs: one-to-one relation and one to K learning elements relation. Using these precedence relations between learning elements, we can build a common Petri net model for each module. And for each module, the common Petri net might be represented by 4 places and 8 transitions, as you can see it on the picture. The places represent the states of learning elements as for their readiness to be learned by students due to their relations precedence. There is always one and only one token on the module, which means that only one of these places can be marked at a time. And the transitions simulate the events of start of learning elements, mastering and accomplishing them. So in such a way, we provide so-called synchronization of learning learning elements. Then net addition is done by merging transitions, so-called learning able to start of dependent module and learning ready to continue, a learning element ready to continue of previous module. There are 3 situations how to add the modules to create a course due to different types of precedents, as you can see it on pictures A, B, and C. The Petri net representation of 2 modules presented by common Petri nets after applying the rules presented before using the net addition operation, considering and precedence for A picture and or precedence for B picture. So summarizing such an approach, we can say that the built Petri nets represent all the evolution of the learning elements mastered by students in the frames, which are in fact course modules, and between them. Petri net facilities provide grouping learning elements into the frames, taking into account precedence of their learning. And the frame facilities provide spreading the set links between the learning elements within the module and between the modules of different disciplines. Such a modeling for shaping the frames, in fact, modules of university courses provides synchronization of learning elements mastering and at the same time keeping links between them. So characterizing the potential benefits of the offered approach to the courses modeling, we can realize mechanisms in such a way, we can realize mechanisms of knowledge penetration in curriculum subjects, optimize sequence and coherence of learning, build individual learning paths for students, etc. So also it might be used for formation of educational content for systems of intelligent adaptive learning, innovation curriculum programs creating with interdisciplinary content, effective tests creating, and which is really important for university students, sort of university teachers, using such the results of such an approach of courses modeling. Really important for university teacher because he is able to see and realize the place of each learning element in the system of learning elements of his discipline and the links with other discipline via mutual penetration. And thanks to that, the university teacher can select proper methods and techniques of learning to offer students really interdisciplinary problems to solve, minding revealed links, provide special ways of students' activity in order to form their holistic and flexible system of knowledge and skills. And finally, to save academic time and at the same time to learn with students each element comprehensively, deeply, and from the standpoint of various disciplines. So our work is in progress, and that's all for today. I'm ready to answer your questions. Thank you for your attention.